Hi, my name is Mikayla Cox, and this is my video for the summary of learning for science this semester. So the first question we had was, what is a science misconception? So a science misconception, in my terms, is something that an individual knows to be true and correct, but scientifically is incorrect or cannot be backed up with scientific proof. So a couple examples of that that students often have examples of as misconceptions are, you can touch a rainbow. So students often see a rainbow and they're like, I want to touch it. Well, that you can't. We all know that rainbows are just a reflection of the sun off of water, but as students, the young students, they just see it, they see color, they see something that bends, and they think, oh, they can touch it. Another misconception would be that the sun is the same size as the moon, because they don't realize that the sun and the moon are different distances from the earth. So later on you learn that the position in the sky has to do with our perception of it. I will definitely utilize students' misconceptions during instruction because I think it's really important to start with their prior knowledge and what they believe to be true and then build off of that. So if possible, I would give students like a pre-test at the beginning of the year if I knew what all I was going to cover, just to gauge the misconceptions and then build on them during instruction. And when teaching, I would be sure to discuss and hit upon the major misconceptions that students have, and I would acknowledge why they probably had those misconceptions and why it was okay to have those misconceptions, and then go on to why those are misconceptions and not true, based off of scientific evidence. So the next thing was progression of standards. So the progression of standards is where students start learning about a topic or a standard in the lower grades, and it's a very basis, very entry level learning of that topic, and then throughout their educational career they learn about the same standard but on a more in-depth level. So an example of this would be, the standard is ESS2.C, and it's the roles of water in Earth's surface processes. So in the grades kindergarten through second grade, they would learn about water and how it's found in many types on Earth, types of places, and in different forms. And then in grades 3 through 5, they would kind of go in more in depth on that, and then they would learn about how Earth's water is mostly in oceans, and most of Earth's fresh water is in glaciers or undergrounds. And then grades 6 through 8, they would learn about water cycles and on land, ocean, and atmosphere, water movement, that kind of thing. And then in grades 9 through 12, they would learn about the planet's dynamics and how it's influenced by water. So the next thing I was tasked with was talking about the progression of the standard 5-PS1-3, and if I were to teach this in my classroom. So students would come in with a prior knowledge of states of matter, so just a basic solid, liquid, gas, and we'll know that these different states of matter exist in different substances. And then with that standard, in the 5th grade, they would learn how to use measurements and observable factors to identify different materials and what state of matter those materials are in through those observable factors. And then continuing on with that standard, after that grade, they would learn about atoms and how, on the molecular level, how those relate to properties and that kind of stuff. So it starts with a very basic identification of solid, liquid, gas, and then eventually gets into the molecular level of things. Next was the 5E learning cycle, and the first step is engage, then explore, then explain, elaborate, and evaluate. So in engage, we really strive to engage the individual student to get involved in an activity that has to do with scientific inquiry. So whether that be reading a book or anything like that. The second one is explore. So we want to get students hands-on doing something, interacting with the scientific experiment that they're going to be learning about. And then there's explain, and that's when the teacher helps make connections between the scientific facts that they're going to be learning about and what they just did in the explore stage. and they will also confront the prior knowledge that they have about this fact. In the elaborate stage, the students make connections between what they've learned, and they can make designs, they can connect the scientific concept to their lives. They're really using what they've learned to basically elaborate, like it says, on the topic. And then evaluate is where the teachers assess whether the students have learned what they've just been taught. So an example from one of my 5E lesson plans that I created, in the Engage, I had the teacher reading a book called Monster Plants. This standard was about plants and their internal and external structures. So in the Engage, the teacher would read a book about monster plants. The Explore, the students would play a matching card game with parts of the plant and their functions. So they would work independently to try and match those together correctly and then help each other out. Explain, the teacher would play 2 different videos about like different unique kind of plants, and those videos would explain the different parts of the plants and what they do. Elaborate, the students would work with a partner to research a monster plant, and then they would design their own monster plant based on the facts they found about that monster plant that they researched. And they would make sure to list the properties that their plant had and how it helped out. And their evaluation was students would take those blueprints, those designs that they had for their monster plant, and they would create it into a model and share it with the class. The engineering design process was next. So the different processes are ask, imagine, plan, create, and improve. So ask, you're asking what is the problem, how have other people address this problem, what things are holding me back. Imagine, you're thinking about what can I do, what are some solutions, you're brainstorming. Plan, you're planning, you're making a list of what you need, what you're going to do. Create, you're following your plan and you're testing it out. And then improve, this is where the deep learning happens, I believe, in my opinion, because improve, you're taking what happened in the create when you tested it out and you're figuring out what happened good and what happened bad and how you can modify it. And this is where students really work and use their brains to kind of think of different ways to make that product work better. The things that I thought were helpful in this class, I really thought creating a 5E lesson plan and then teaching it to our classes was really helpful because the 5E lesson plan creating process looks daunting. It's very scary at first, so it was very nice to be able to create one and then teach it and get feedback from my peers and my teacher in class before going out and doing it in my real life classroom as a full-blown teacher. Something that I thought maybe wasn't as helpful as that was the partner activities, small partner activities, when we would write answers on a big piece of paper and share it. I thought that what we talked about during those activities were helpful, but I don't think the way that we shared it and worked with that information was as helpful as it could be. But yeah, love this class. Great semester.